Isometric exercise, in which muscles exert force without changing length, has become really popular in recent times, both in terms of isometric training and isometric testing. But why is that? In this video, we're going to take a look at the science underpinning isometrics and why they have become so popular in recent times. I'm Jo Clubb, sports scientist and founder of Global Performance Insights, which provides sports science consultancy services to sports teams, sports tech companies, and athletes and practitioners all around the world. Firstly, what is isometric training and how is it different then from concentric and eccentric? Well, to answer this, we need to go back to understanding our force velocity relationship. So, this figure is taken from a review article in the Frontiers Physiology journal led by Julian Alcazar. And we can see this sigmoid curve to represent the relationship between force and velocity. So, with positive velocity, those relate to our concentric muscle actions, whereby when velocity increases, force decreases. Conversely, on the other side, we see negative velocity, and this relates to our eccentric contractions. Then at zero, the force generated at this point is determined by our isometric contractions. Put simply, then, isometric demands require static contractions of the muscle in which it is not changing length. Although technically, there is muscle shortening during an isometric contraction due to tendon creep, which is the lengthening then of the tendon whilst under contraction. Now, there are two main types of isometric action. The pushing isometric muscle action, or PIMA, is commonly referred to as overcoming isometrics. These are when a muscle exerts force against an immovable object, such as an overloaded barbell or a machine, preventing movement. So, in a PIMA, the muscle attempts a concentric action, but the joint does not move because the external load is too heavy to overcome. The holding isometric muscle action, or HEMA, are commonly referred to as yielding isometrics. And these are when a muscle resists the flexion or extension of a joint by applying an opposing force equal to the mass being held. So in a HEMA, therefore, it resists an eccentric action by exerting enough force to avoid joint motion and muscle lengthening. So we can think of it as a PIMA, or overcoming isometrics are almost like a stopped concentric muscle action, whereas the HEMA, or yielding isometrics, are like a stopped eccentric muscle action. There are a number of reasons why isometrics have become seemingly so much more popular in recent times, although, of course, they have long been executed both in terms of training and testing in sporting and clinic settings. But I think there are four main areas that justify why isometrics have become so popular. For me, this is due to their effectiveness, their safety, their versatility, and the added benefit of having technology to support collecting information from these exercises. And research has shown that isometric training can lead to strength gains in both untrained and trained populations. But it's not just strength as well. We can see gains in hypertrophy, rate of force development, and tendon stiffness with isometric training. And crucially, isometric training seems to elicit some of these gains in perhaps a more efficient manner. Anyone with an interest in isometrics should certainly dive deeper into Danny Lum's work. But let's just pick out a couple of studies then that demonstrate this. In this study, for instance, in kayaking, which crucially was a randomized controlled trial, so a high standard of evidence, they found replacing half the volume of dynamic exercise with isometric training could result in greater strength improvements than purely performing the dynamic exercise alone. This study also supports the efficiency of isometric training, as they demonstrated a greater training impulse and yet a quicker recovery in these resistant trained athletes based on isometric training. Isometric training is also effective in terms of adaptations in tendon. There are a number of key papers from the researcher Kubo on this topic, including this one that showed that isometric training resulted in greater improvements in tendon stiffness, although less improvements in active muscle stiffness when compared to plyometric training. The next reason then for their popularity is their safety, because isometric exercises are self-limiting. So whilst they might be used by all athletes and clients, they're particularly of interest to those with joint issues or those recovering from injury. Low intensity isometric exercises can be introduced particularly early on to provide a stimulus and to try and reduce the risk of atrophy. And because isometrics don't involve movement of the joints, they can also be used when injured athletes don't even have full range of motion yet. So this figure is taken from a hamstring rehab case study from Nicole Van Dyke, which is in Vald's free practitioner's guide to isometrics, which I'll pop a link to below because it is a fantastic in-depth resource, absolutely free, that gives you really good information about the science and application of isometric training. In this example, we see how it could be incorporated into the early stages of a hamstring rehab process. These exercises are self-limiting and they're conducted within safe ranges for that injury and that point of the rehab that will help to build strength. Now, with access to technology, we could also add objectivity to this process, as I'll discuss further shortly. Next up then is their versatility. They can be performed anywhere with minimal equipment, and you can just use your creativity to come up with the most appropriate isometric exercise. This versatility aids in making them really practical exercises, whether that's to give to a client who is recovering from injury as part of the clinic setting, but then also with athletes who are traveling, who are on the road, or even just don't want to go out of their way to the gym to do their pre-training prehab exercises. Often you can perform these right on the side of the pitch. Again, this figure is taken from Vald's free practitioner guide to isometrics. And I think this really highlights the versatility of this form of exercise. Now, of course, isometric training has long been around, but I think this heightened attention in recent times is driven by this versatility and creativity of training using this approach, and also then pairing that with objective information via technology. Linked to that then is the four main areas for this popularity in isometric training and testing, and that is the technological advances that have enabled exercises to be quantified and tracked over time in a very practical manner. We talked throughout this series about training as testing and testing as training. And when isometric exercises are frequently incorporated into the training program, that we can quantify the force that that individual is generated and then track that over time just as part of their weekly training program. So these tests can be done either as a multi-joint assessment, such as the isometric mid-thigh pull, or a single joint assessment, which might be some of the hip and groin examples we've talked about, as well as perhaps a shoulder ASH test, for example. In the case of the isometric test, then depending on the technology used, the athlete is applying that force to some form of this technology, whether that's a force cell built into a force plate or perhaps built into a dynamometer, in which the technology is collecting the force that the individual is generating in that position. But it's not just force as well. We can get a number of other measures depending on how you are cueing the test, such as rate of force development, as well as asymmetries between the left and right-sided force outputs, if those are relevant to that test. Now, I'll include a link to our playlist for our athlete testing series, so you can take a look through and see which videos might be of most interest to you. And of course, if there's a topic or a test that hasn't been covered yet, then do please let me know. You can either comment below on the video in the community tab or get in touch via my website or social media. I hope you found this video useful. And if you did, please hit like and subscribe to make sure you don't miss out on another one. And a massive thank you to Val Performance for sponsoring this video, this whole series. And of course, as I mentioned, if you want more information on isometrics, then definitely get their free practitioner's guide to isometrics, which I will link to below. And I will see you again soon for another Sports Science Insights video.